Okay, today TCP/IP is the most used protocol over networks. In order to use this protocol, a device needs an IP address. Part of the TCP/IP is the IP. There are two types of IP addresses, version 4 and version 6. Most of the time we use version 4 addresses, although version 6 is finally picking up some traction. We ran out of IPv4 addresses on the public internet, but the way we do things and have configured some workarounds, most of the time most machines still have an IPv4 address that's called a private IP address, and then all the devices behind the routers share IP addresses, and we'll get into that a little bit later. But finally, version 6, it's a much newer version, much more secure version. It is starting to pick up some traction. Version 6 is a 132-bit address, whereas version 4 is a 32-bit address. And that's just how many zeros and ones make up, because they're binary. They use binary. So there's 132 binary digits in a version 6, and there's only 32 binary digits in a version 4. And version 6, like I said, has built-in security, where version 4 has no security. All security was bolted on after it was created. But version 4 is much easier for humans to read, remember, and use, because it's only 32-bit address. And you can see here the 32-bit version 4, 10.10.10.10. That's an example of an IPv4 address, whereas this 2001:0 DB8:3:0:8:8 is an example of IP version 6. And as you can tell, it's very easy for a human to remember the IP version 4 number, where it's literally impossible for a human to memorize or use the IPv6 without writing it down or copying and pasting, just due to its length. It's just overwhelming for most humans to be able to remember all those digits. But it's more secure. It provides us so many more IP addresses. Like I said, the IP version 4 is only like 4 billion IP addresses. So we ran out. And as far as the number of IPv6, it's an unfathomable amount of numbers. Basically, there's enough IPv6 addresses to assign everybody in the world an IP address, and I think possibly even because that's easy, but I think it's even that every cell in everybody's body, everybody on the planet could have an IP address. I mean, it's that many numbers. It's unfathomable. Okay, there are two ways to assign IP addresses to a device or host. The first way, which is typical for most organizations and most home user settings, is to dynamically set it, and I've mentioned this before, via DHCP, which is known as the Dynamic Host Configuration Protocol, or DHCP service. With this technique, a server, router, or other device acts as a DHCP server, and it issues IPs addresses to any device that requests an IP. The DHCP server supplies the device with an IP address and a subnet mask. if it's using IPv4, and typically will supply a default gateway and DNS server as well to the device. However, if you're going to use the device to only connect to local devices on a single private network and will only use IP addresses to connect them, you do not need to supply a gateway or DNS server. You need a gateway if you plan to connect to devices such as web servers or any device that is not on your network. If you need a DNS, you need a DNS server if you plan to use domain names instead of IP addresses to connect to devices. For example, if you wanted to connect to Google, you can, well, let me just show you here. So let me open up Chrome here. So we can go to google.com, right, and so it comes up, or let me get this, or I can go to Google DPS access / 216.5.8.194.78, and that's okay. Let's say proceed, and so now I've got to Google anyway by going by its IP address. So I got to Google.com, and you see that it rewrote it to google.com, even though I went to it by its IP address. That's just because Google is smart enough. It really should just stay as the IP address, but it rewrote the page knowing that I was going to google.com. But so you can access a page either going through its domain name. If you use the domain name like google.com, you need DNS, and so you need to have your DNS server set. And also, since I'm going to google.com, I need a gateway because Google servers do not exist on my home network. So I need to use a router, which is a gateway. A gateway is a router, but the gateway is your router that you need to talk to and send requests to for other networks. So a gateway or router, they're the same thing, but you need to have a default gateway set up. Where do you send requests? Your IP requests to if you need to go outside your network. That's your default gateway, and so with a typical network, you'll have your IP address, a subnet mask. All the subnet mask is doing is telling us from that IP address what network am I on, because the subnet mask tells us what bits of the IP address are the network address and what bits are my computer's identifier. So in this example, the subnet mask is 255.255.255, which you'll learn it means that the first 24 bits, because there's 8 bits in each of these sections, and so I have 3 sections with all 8 bits set, and 8 bits set equals 255. Well, where's my mouse? There it is. And I can't get it over there. Okay. And so the first 24 means that the 192, the 168, and the 100 identify my network, right? So I'm on the 192, 168, 100 network, and my machine is machine 4 or IP4 on that network. That's what that's telling me. But so on an IPv4, you need to have a subnet mask. IPv6, because we have so many bits, the subnet mask or the network number is actually built into the IP, so we don't need a separate subnet mask. The IP itself tells you what network the IP is on, as well as what machine on that network it is. So you only need a subnet mask if you're using IP4. Okay, the second way to configure a host device on a network is to manually set the information. Right? So we go into our network connections window, right, and go into our networking and then get to our properties. So let's, I go this way. I just right click on our network device again, right? Open up network and interface, and then you can change your adapter options, right? Or you can go to Ethernet and change your either way. But basically, you need to get to your control panel's network connections. Right click on your connection that you're wanting to administer, go to properties, and then once again, depending on are you doing IPv6 or IPv4, we're going to be doing the 4 because this is what you're normally going to be dealing with most of the time, even today. And then you would set your manual address. Once again, this is DHCP, right? But you can manually set your IP addresses and your DNS servers. Notice that you have a default gateway here. You need to set that. Otherwise, you can't talk to any device off your network. If you leave off the default gateway, you can only talk to devices on your local network. So you need to make sure that you set your gateway correctly. But once again, this is DHCP because I have DHCP set up so that it'll get out correctly. And let's see here. So just make sure, and DNS servers, right? You need to have your DNS servers if you want to use your DNS as well. You can enter up to 2 servers so that if the first one doesn't work, you got the second one. You can use public DNS servers, like Google has public DNS servers that anyone can use. They're 8.8.8.8 and 8.8.4.4. Those are Google's public DNS servers, and you'll see me use those frequently in some labs and things. So that's, you can either do dynamic through DHCP or you can do static or manually. And then this is just showing a static setting using the settings app, which you can use that through the settings app as well. I prefer going through the network connections tab in the properties tab. And then you have the alternate IP address configuration. So say, for example, if you move between networks, home and work, right? And one of those networks does not have DHCP, and you need to have a static address. In this case, you would enter in your manual IP address information on the alternate config tab. Then anytime you're not able to access DHCP, you'll be able to switch to the static IP information, right? So here's an example of the alternate configuration. You have the automatic private IP address, or you can use the user config address. So and you just put in the information. So You got your IP address, subnet mask, default gateway, preferred DNS servers, Win servers. They're similar to DNS, but if your network uses them, you'll have them. But a lot of times you're not using those anymore. But they're there if needed. And so just to see how this looks, right? So if you go here on our network again, right, and we go to TCP I4, right? So we've got DHCP set, and we have the alternate configuration tab. So if this was a laptop that I can move, and one of the places I had did not have DNS or DHCP, I could set this up and say, okay, when you don't find DHCP, use this IP address and subnet mask and gateway and all this information. So this is my alternate configuration if DHCP is not available. So that it makes it easy to move from those two locations, right? So I'm just going to leave that as it was, but that's our alternate IP address config. All right. Computers use a network interface card or NIC to connect to the network. The NIC may be a part of the motherboard. It may be a separate card plugged into the motherboard, or it may even be an external device connected via USB. The network interface card, NIC, may be a wired card or a wireless card. Either way, you need drivers for the operating system to use the card. A NIC can operate in full or half duplex mode. Full duplex mode allows the card to send and receive data at the same time, where half duplex mode, the card can only send or receive data at any one time. So it can't do both. And if it's half duplex, it can only send or receive at any one time. Every NIC has a 48-bit identifier called a MAC address, and this is unique for that card, and it even tells you who manufactured the card. The first 24 bits, binary digits, tell you the manufacturer, and the last 24 binary bits identify the exact card. And so switches use the MAC address of devices to direct data traffic. Switches don't use the IP address because it uses the MAC address. If you're staying local on a local network, you use MAC addresses, and the switches know what port is plugged into them and what MAC address is on that port. If you need to go off your network, that's when you use IP addresses, and you use routers, and routers use IP addresses. But switches use the MAC address, and every network card has its own unique MAC address. Network cards typically have status lights, and if the system is configured properly, can even wake up a computer when data is received. If your computer's asleep, you can wake it up by sending it data if it's properly configured. For some networks, we need to have the ability to prioritize network traffic, and we use quality assurance, or QoS, to describe this process. And to prioritize traffic on a network, the network cards and routers must be configured to handle this. I've talked a little bit about routers, but so we're going to talk about this small office, home office router, or SOHO routers. A router is a device that manages traffic between two or more networks. And to set up our SOHO network, or small office, home office, you need to know how to configure a multi-purpose router. The multi-purpose router combines multiple network features such as a router, switch, DHCP server, firewall. They're all in together. Each one of these is actually its own, could be its own device, but and typically are different devices on a large organization's network. But in the small office or home we're going to use a multi-purpose device that has all these features or most of these features in one device. A typical SOHO router will have the following features. First, it's a router, and it will manage the traffic between the home network and the internet and other networks. Next, it will have several switch ports, so it can have multiple connected wired computers or devices, such as a printer and desktop computers. It will be a DHCP server capable of handing out IP addresses to the home devices. It will usually be a wireless access point, which allows wireless devices to connect to the network and internet. And it will be a firewall, enabling you to block unwanted traffic from the internet. And finally, it can be a FTP server, file transfer protocol server, or file server, allowing devices to share and store files to a connected external hard drive. When installing a new SOHO router, you should consider the accessibility of the router, and you might want to place it in a secure location such as behind a locked door, but also you'll want it in a centrally located location if it's also a wireless access point. You configure a SOHO router through the browser by entering the default IP address for the router. Typically, the username to connect is admin, but refer to your router's documentation. The default password is typically found on the device or in the documentation. One of the reasons to have it in a secured location because the password is typically on the device. Every router is different, so follow the user guide or poke around the items until you find the features and settings you need. Always remember to save the changes and log out and close the browser. Right. So here's an example of a typical SOHO router configuration page. Right. So you can see up there it went, it went to the 192.168.1.1 IP address, which is probably typical. It's usually 192.168.1.1 or 192.168.1.254. Those are typically default IP addresses for home SOHO routers. But you can see you can manage your internet, you can manage the wireless, you can manage attached devices, you have some parental controls, got the file sharing ready to share, you can have a guest network, and that's just the basic. And then the routing, the advanced tab has even more features like your firewall and things like that. But this is just a typical SOHO router configuration page. All right, so changes you might need to make on the router, right? Change the router's default password, configure the DHCP server, reserve IP addresses, right? So for example, like a printer, you might want to reserve certain IP addresses from the DHCP server, so the printer always gets the same IP address, so that it doesn't get changed, so the printing stops working. You can do MAC address filtering to make it more secure, so that only known devices, you can put in a list of MAC addresses for each one of your devices, and only those devices can use the router. It's okay for a home situation, but I mean, if you're doing more than 3 or 4 people, right, it's not going to be very easy, or if you allow people to bring stuff in, it's going to be a pain to keep track of and keep up to date. But it's an option. QoS for applications or devices, like if you're doing voice over IP, things like that, those are typical things that you would do QoS for. some universal plug and play, and then updating the router firmware are all things you may need to configure. All right, so limiting internet traffic on your network, right? So firewall can examine each packet and decide if its packet is allowed onto the network or off the network. And a packet is directed to a particular computer and to a particular application running on a particular port on the computer. That's how packets are set up. And the application is identified by the port number, also known as the port address. So for example, web traffic runs on port 80, whereas secured web traffic runs on port 443. And you have the option to disable or close all ports, which would mean no access to anything. So nothing would be allowed if you disable and close all ports. You can then allow exceptions for specific computers or applications. So you could say, my laptop at this IP address has access to web traffic, port 80 and 443, but nobody else, right? So exceptions are typically allowed for port forwarding or for a DMZ. DMZ, or demilitarized zone, is typically where organizations place their web servers, as users from the internet should be allowed access to the web servers so that they can view the website. So typically, right, you don't have anything that you want coming in from the internet. But if you had a web server, you would want something, the users to be able to come in and get to your web server. So you would put that outside the firewall, typically, in your demilitarized zone. All right. Each application on a computer is assigned a unique port number. There are some, each application that has access to the networks, any network application, will be assigned a unique port number. And there are some well-known, well-defined ports that are used, because there are only 65,536 ports available on any computer. The first 1,024 ports, port numbers 0, we start at 0, to 123, are called the well-known ports and are used by major internet services and well-known applications. For example, port 25 is used for sending email, whereas port 80 is used for non-secure web pages. Port 53 is used for DNS. Port 110 is for pop email, for reading email. So those are the well-known ports. So anything under 1023. 1024 to 49,151 are what are known as register ports. And then certain organizations or vendors, software developers, have the ability to register their applications to those ports. An example is port 3,389 or 3389 is registered to Microsoft for the Remote Desktop Protocol, RDP. So they registered that port and they own that port for their applications. Only their application should run on that port. Ports 49,152 to 65,535 are called dynamic or private ports, and any application can use them as long as it is currently open and free on that computer. And here in this depiction, right, you have some web traffic, HTTP data. So it's addressed to this computer with the IP address of 138.60.35, port 80, and so it's going to the web server on that computer, right? Port forwarding is used when you want to access your computer or application over the internet. Is one reason. For example, you are at work and want to access your home computer or application running on your home computer um, from at the coffee shop or and or maybe you're at the coffee shop or work and you want to access your home computer or application running or any application running on your home computer. So typically you will need a static IP from your ISP, or manual IP address, not a DHCP. And this means you purchase a public IP address from your ISP so that you always get the same IP address. That way you can access your computer as you know the IP address, your public IP address, and you can then also buy a domain name and register your domain name with DNS servers, so then you can access your computer at home by a name, right? So, but you can also use a service known as dynamic DNS, which allows you to run software on your computer that will go out and register your DHCP IP address that was assigned to you and allow you to access your computer that way. It's a bit more tricky and may violate your terms of service with your ISP, so verify that before you do that. Typically, you pay for a public IP address, and then that way you can access your computer, and then you set it up in the router. That'll takes your internal address and maps it to the external address that you bought from your ISP, and then you can access it. Typically, but not always, you will set the external port to the same as the internal port. For example, if you want to allow web traffic through to your web server and the web server is running on port 80, so you would typically map port 80 on the router to port 80 on the web server. However, you could use a different port on the outside. So for example, you could say port 49,000 maps to the web server on port 80. You would have to have users specify the port number, such as my address colon 49,000, because you're using something else other than 80, where my IP address is the actual IP address of your router, and then if you use the default port of 80, you would just type in your IP address and the browser would automatically add port 80 because that's the standard for web traffic. By enabling port forwarding, you are allowing users from outside your network to initiate and connect to your network. Right. Normally, your firewall will block incoming packets that are not a return from something that you requested. So if you request something and it comes back in, of course it allows that in. But something that just comes at you and you didn't request it, it usually blocks that. So by enabling port forwarding, you tell the firewall it's okay for certain traffic to be able to come through the firewall that you didn't request. In this picture, someone is accessing the remote desktop server at IP address 192.168.190. As the packet is coming into the router, which the router is located at 72.13.18.200, right? And the packet is going to port 3389, which we said is Microsoft's remote desktop protocol application that's registered to Microsoft for remote desktop protocol. So in this situation, the external port on the router has port 3389 set and then mapped to internal port 3389 for the actual internal server, the remote desktop server located at the 192.168.1.90 address, right? And so All right, so that's the port forwarding, the packets coming in. It goes to the public address, the 72.13.18200, which is the router. Router has your public address, and then they're using the same ports, the 3389 and 3389, so makes it easier and simpler to use the actual application ports and make them the same. They don't have to match, but they should typically match. And then so the router gets it and says, that's 3389. You actually want the remote desktop server, because that's where my port mapping goes to. Alright, a DMZ is a less secured area, as you need to allow outside access to the systems within the DMZ. DMZ lives outside of your firewall, and typically for a large organization, the DMZ will live between two firewalls. The first exterior firewall will allow certain traffic into the DMZ, but that is it. And then there's another firewall called the internal firewall that only allows traffic from the DMZ systems if and only if it is going to certain systems on certain ports. For example, a web server in the DMZ, right? So users can get to the web server going through the external firewall. They get to the web server, but only the web server can go to the database that has the data that the users might need. The users can't go directly to the database. The web server has to go to the database. And that's the only thing that can go through the internal firewall to the database. This creates a more secure network, as you are still controlling some of the traffic and not allowing everything to get to your DMZ, and you're very limited on what can get to your database servers. Another way you can limit traffic on your network is through the use of content filtering or parental controls. This can be set to block certain websites and applications based on their domain names or IP addresses. Some of these use blacklist or whitelist. A blacklist is a list of sites that cannot be accessed, whereas a whitelist is a list of the only allowed sites. Whitelists are very hard to support, as it would be very rare for you to include and think of every possible website a group or user could need. It might work well if you're controlling access for your child, though, as you could add a site at any time and would allow you to have total control of what they had access to. Blacklists are easier to manage, but will not always contain every site you wish to block. So some filters allow for blocking keywords or categories in order to help catch more sites than a typical blacklist can provide, but still it's never going to be 100%. Whitelist or blacklist, there's downsides to both. You're never going to be able to block everything, and you're never going to be able to think of everything to allow, right? But those are your options. You can definitely control and filter out a large portion, though, of the sites. And definitely with whitelist, you can block everything except for what you've got listed that's allowed. And here's an example where you can type in the keywords and domain names that you can block. So that ends our section here on IP addresses and limiting traffic. Our next video will cover setting up wireless networks.